Imagine waking up one morning and reading the headline. It has finally happened. Every square kilometer of the ocean floor has been mapped. Every trench, every ridge, every hidden cave, every creature that lives in the deep has been photographed at least once. Every hydrothermal vent has been cataloged. Every underwater mountain has been named. The ocean, all of it, has been seen. For most of human history, this was a fantasy, a children's story, a line in a science fiction novel. 95% of the ocean has never been explored. The deep sea holds more habitable volume than every other environment on Earth combined. And yet, in this imagined future, we have finished the map. What would change? The answer is more disturbing and more beautiful than most people realize. Most people assume that fully mapping the ocean would be like fully mapping a forest. You get better data. You find some new species. Scientists have a nicer database. Life continues. The science says otherwise. The consequences of a complete ocean map would rewrite biology, medicine, energy, geopolitics, and possibly our understanding of what it means to be alive on this planet. Let us begin with the smallest change. And the most obvious, the number of known species on Earth would multiply. Right now, biologists have described roughly 2.2 million species. Marine biologist Ward Appeltans, coordinator of the World Register of Marine Species, has estimated that between 1 and 10 million species may exist in the ocean alone, most of them completely undescribed. If we explored 100% of the ocean, the current catalog of life on Earth would likely double, possibly triple. Almost every deep-sea expedition that has ever occurred has brought back new species, in some cases, dozens per trip. Imagine that pace, sustained for years across every ocean basin. You would wake up in a world where the fossil record was suddenly the smaller part of biology, where the number of animals humans had never named would drop from millions to zero, where the phrase new species would stop appearing in headlines because it would be happening every day. But that is only the beginning. Here is where it gets interesting. The deep ocean is not just a place where new species live, it is where new chemistry lives. Bacteria that survive by eating rocks. Worms that thrive inside boiling hydrothermal vents, fish that produce their own light through molecules, unlike anything in surface biology. Every one of these organisms is a chemistry factory, and every chemistry factory is a potential medicine. Ziconotide, a powerful painkiller stronger than morphine, was derived from the venom of a cone snail. Cytarabine, used to treat leukemia, comes from a Caribbean sponge. Trabectedin, used in cancer treatment, was extracted from a sea squirt discovered in the mangroves. We have found these compounds through scattered, opportunistic sampling of maybe 5% of the ocean. In a world where we have explored 100%, the number of potential drugs would be almost impossible to overstate. Marine chemist William Fenical of Scripps Institution of Oceanography has spent his career searching the seas for compounds that might treat human disease. His team has found antibiotic candidates in deep-sea microbes that no land-based organism produces. If every ocean environment were sampled, the pipeline of new antibiotics alone could reshape medicine in a world where existing antibiotics are losing effectiveness against resistant bacteria. The people who die from infections we cannot treat right now might be saved by molecules floating in water we have never seen. But that is not the strange part. The strange part is what a complete ocean map would do to our understanding of Earth itself. The ocean floor is not a smooth basin. It is the most dynamic geological environment on the planet. Marine geologist Marie Tharp, working in the 1950s, was the first person to systematically map the Mid-Atlantic Ridge. Her drawings revealed a chain of underwater mountains stretching more than 65,000 kilometers around the globe. This discovery helped confirm the theory of plate tectonics, which was still controversial at the time. Her work changed geology forever, and THARP mapped less than 1% of the seafloor. At full resolution, the ocean floor would reveal fault lines we have not yet found, volcanoes we have not yet catalogued, ancient river valleys carved into the continental shelves during ice ages when sea levels were 300 meters lower than today. Entire drowned landscapes would appear. Doggerland, the sunken plain between Britain and Denmark, where humans once hunted mammoths, is only one of dozens of similar landscapes hidden beneath modern seas. A complete map would reveal everyone. We would find lost cities, not the mythical kind, the real kind. Off the coast of India, off the coast of Japan, off the coast of Egypt, submerged human settlements have already been documented in shallow water. In a world where every meter of coastal seafloor is scanned at high resolution, entire civilizations that were washed away by rising seas at the end of the last ice age would come back into view. Some of them older than the pyramids, some of them older than agriculture, some of them possibly rewriting the timeline of human history. You would wake up in a world where the story of how humans lived was suddenly incomplete, because the older part had been sitting underwater the whole time. Here is where the science becomes harder to explain. A complete ocean map would also transform how we understand climate. The ocean absorbs roughly a quarter of the carbon dioxide humans release into the atmosphere. It has slowed the pace of warming considerably, but the mechanisms are only partially understood. Where does the carbon go? How long does it stay? What role do deep-sea currents play? What happens when those currents change? Oceanographer Susan Lozier at Georgia Tech has been leading research on the Atlantic meridional overturning circulation, the current system that includes the Gulf Stream. It is a critical component of global climate, and it is showing signs of weakening. If we mapped 100% of the ocean, including every deep current, every seasonal shift, every microscopic exchange between water and organism, our ability to model climate change would leap forward. We would know, with much greater precision, how much time we have. We would also know, with much greater precision, what we have already done, because a complete map would also reveal the damage. Plastic that has drifted into the deepest trenches, already documented at the bottom of the Mariana. Chemical pollutants that have accumulated in deep sea animals in concentrations no one predicted. Coral graveyards, fishing nets abandoned on the seafloor, still catching animals decades later. The ocean is not just a place we have not explored. It is a place we have already changed without seeing. A complete map would force us to look at what we have done. And then something unexpected would happen. We would find something that does not belong. If you sample enough of the deep sea, you will eventually find something that current biology cannot explain. That has been the pattern for the last 200 years. Every time we look somewhere new, we find something impossible. The coelacanth, a fish thought to have gone extinct 65 million years ago, was found alive off South Africa in 1938. The giant squid, dismissed as a myth for 2,000 years, was filmed alive for the first time in 2004. The hairy chest crab, the eyeless shrimp of the Cayman Trough, the yeti crab that farms bacteria on its own arms. Each one was, at the moment of its discovery, considered impossible. The pattern is consistent. If we explore, we find. If we find, biology has to expand to include it. A complete ocean map would almost certainly reveal a creature that redefines how we think about life. Perhaps one that runs on chemistry no one has seen before. Perhaps one that lives at temperatures we assumed were lethal. Perhaps one that survives without any oxygen at all. There are already candidates. In 2020, researchers led by Lisa Levin at Scripps documented deep-sea animals that appear to thrive in oxygen-free water. The rules of life are looser than we thought. At the deepest level, exploring the ocean is not really about finding new species. It is about finding out what life is actually willing to do. The deeper question is what this map would do to us. For most of human history, we needed the ocean to be a mystery. The unknown was a place where imagination could live, where stories could be born, where the impossible could still be true, because no one had proven it wrong. There is something in the human mind that requires a horizon. Something that reaches, that dreams, that turns unknowns into stories. What happens when the horizon is gone? Marine ecologist Sylvia Earle has spent her life arguing that we should explore the ocean, not just for the science, but for the perspective, because seeing it, really seeing it, changes something in a person. When you understand how much of the planet is water and how much of the water is alive, the small worries of daily life shrink. Not out of insignificance, but out of proportion. In a world where we have explored 100% of the ocean, we would have seen the most enormous thing on Earth. Fully, completely. And in seeing it, we would understand for the first time how small the parts of the planet we normally think about actually are. The cities, the roads, the countries, the politics. All of it would sit in perspective against the reality of a living world that is mostly quietly hidden below the surface. The final consequence of exploring the whole ocean might not be scientific. It might be philosophical. For the first time in the history of our species, we would truly know where we live. Right now, you live on a rock. The rock has a thin atmosphere. Underneath the atmosphere is a wide, dark, unmapped world that covers 70% of the surface. In the imagined future, that world becomes visible. You would know the mountains beneath the waves. You would know the trenches carved into the crust. You would know the creatures that live where you cannot go. You would know the currents that shape your climate. You would know the drowned villages where your ancestors may have lived. You would know your planet. And when you looked at the ocean from that beach, it would still stretch to the horizon. It would still meet the sky, but you would know what was underneath. And knowing might not make it smaller. It might make you feel, for the first time, how big it actually is. Thanks for watching. If you enjoyed this, subscribe for more videos like it. See you in the next one.